Welcome everybody to another episode of MongoDB TV Cloud Connect. I'm Shane McAllister. I'm on the developer relations team here at MongoDB, and I'm the host for Cloud Connect, which streams every Thursday, usually most Thursdays, on what's good and exciting in the world of all things developer related. And today is no different, where we're going to dive yet again into the world of generative AI. This time, generative AI with AWS. We're going to be discussing services, deployments, and RAG with Bedrock, amongst other things. But first, some housekeeping. So while we get ready for today's stream, do drop a shout out in the chat. Tell us who you are, where you're joining us from. We really do love to see where our viewers are joining from all across the globe, and we love to hear from you. Plus, once the show kicks off, as ever, feel free to drop in any comments, any questions that you might have into the chat, either on YouTube or LinkedIn. And we'll either tackle them live if it makes sense to do it at that time. And if not, we'll hope to get some time at the end of our session today to answer those questions as well too. If you're a seasoned viewer and you've joined us on Cloud Connect before, you're very welcome. It's great to have you back. And if this is new to you and it's your first time, a very warm welcome to you also. You can dive into our past shows on MongoDB's YouTube channel. You can go in there to the live tab and look at everything we've done before. And on LinkedIn, if you go into our events, you can click on the past events and relive some of these streams as well too, because they are recorded. So don't worry if you don't get to join us for the full show today. You'll be able to go back into YouTube or LinkedIn to see it again. So you can catch any of our recordings of this show or any of the past episodes later at your leisure. Once on LinkedIn and YouTube, don't forget to obviously like and subscribe and to follow us. That way you'll keep up to date with all the latest posts, our latest news, and indeed the notifications for shows and events such as this that might be coming your way. One more announcement before we wrap up and try and get it started with our show is MongoDB is heading out on our world tour, what we call MongoDB.local. And we're doing this in person to bring all the latest news, all the latest kind of presentations directly to you, our audience, wherever you might be. Our first stop is very soon on April 17th in Toronto. And then our biggest event of this .local series is in New York City on May the 2nd. We hope we're going to add additional cities throughout the year. And if you go to mongodb.com/events, you'll be able to see all of those upcoming MongoDB.local events that hopefully will be somewhere near you. And if you are interested in attending, for our audience, we've got a discount code for you. So if you register for any of these .local events, you use the code community50. So the word community and 50 will get you 50% off your registration for our .local events. So with all of that out of the way, let's get on with our show, which is pretty packed today. I'm going to be joined by David and Rustam to explore the various range of approaches for deploying pre-trained large language models, or LLMs, to AWS Cloud using various tools such as SageMaker Jumpstart, SageMaker SDKs, and AWS Copilot. In addition, we'll showcase how to leverage retrieval augmented generation, or RAG as it's more commonly known, with MongoDB Atlas Vector Search and Amazon Bedrock. So to bring these concepts to light, as ever, I'm going to be joined to showcase and to demo these and to illustrate the deployment processes for these models using SageMaker, Jumpstart, and AWS Copilot, and also a demo on how to enable natural language queries to extract more value and insights from your data. In order to do this, I'm going to bring on Rustam and David. You're both very welcome to MongoDB Cloud Connect. How are you?
Hi, Shane. How are you?
Good, good, good. It's great to have you both. I appreciate you taking the time with me to join us here. By way of introductions, and I'll start with you first, Rustam, tell us a little bit about kind of where you are, what your current role is, and maybe your career path to date as well too, because I know our audience joining us are always very interested in, how people got here.
Yeah, thank you. And yeah, that's a great question. So Right now, I'm located in the Bay Area, and I work at a startup called Instrumental as a machine learning engineer. So basically, because it's startup, I do a bit of both like research and machine learning infrastructure. And I became fascinated about machine learning infrastructure in the cloud years ago, and that prompted me to kind of starting a couple of open source projects related to that, and doing some online courses on the topic and presenting at some conferences. Because basically, I think machine learning is a big area, and a lot of people want to actually see machine learning in production. And right now, everything works in the cloud. So you really need to know like how to put them together.
I think that's crucial, and I suppose, look, that's the key thing. I think when we search and we want to get involved in the area of AI and generative AI in particular, we see loads and loads of demos, but we need to see, well, how does that apply to me? How do I deploy that? How do I get that into production? And I love to hear kind of real world examples of how AI is helping people as well too. How long have you been at Instrumental, Rustam?
About 5 years. So
Okay.
pretty long time.
Good, good. And David, you're with AWS. Tell us a little bit about your role there and your career to date and what got you to AWS.
Absolutely, yeah. David Min here, Senior Partner Success Solutions Architect at AWS. I joined about little over 2 years ago, and I started my career as a network engineer at Cisco. So early 2000, and made a few career transitions, anywhere from IP telephony, also known as unified communications, data centers, network compute storage. And then I got fascinated by the cloud, the growth. And then I see the sort of same momentum or even faster momentum from a generative AI standpoint. So, I've been really focusing heavily on Gen AI and try to be a practitioner, making it real and keep it simple. So that's where I am.
Good. I love that, being a practitioner and keeping it simple and making it real as well too. And we've had, I think, one or two of your colleagues seem to be joining us on the live stream. I see one or two AWS folks. For those joining us, please let us know in the comments where you're joining us from and introduce yourselves. We love to see that. And as I said at the introduction, in case you missed it, add any comments in there throughout our session today. We've got a lot to dive into, and it's great to have both of you on board. You both met at, in a MongoDB context at reInvent last November, early December, where you presented for us on the MongoDB stand there as well too. What did you cover there, Rustam? What was your presentation?
Yeah, so basically MongoDB gave me an opportunity to present on the topic of using different ways for hosting large language models on AWS, because there are like more than a couple of ways of doing it. And sometimes it gets confusing. So I try to put together, okay, here are the options, here how they're different, and how you can use them in your project.
Excellent. And we're obviously going to see some of that today as well too. So I'm looking forward to seeing that. And David, then you had a presentation similar to Rustam then as well too on our booth stand there at reInvent.
Yeah, I got a chance to take a look at Rustam's presentation. That was really good, and looking forward to today's session. I cover the retrieval augmented generation over your data. So how to leverage RAG. I use LangChain as well, open source library, to sort of keep it simple, and leveraging the Amazon Bedrock. So I'm going to cover that topic as well today, and a little bit of a demo as well.
Excellent. Well, listen, I'm very much look forward to this. I know our audience are. I can see, 200 plus on LinkedIn are joining us. So again, please drop any questions you can, and we'll try and answer them, at the time when they come in, if it's suitable, and if not, we'll take care of them at the end. So I suppose, Rustam, going back to what you were talking about in terms of kind of, there are several ways to run LLMs and deploy LLMs on AWS. So why don't we get started on that conversation and talk about, how different they are in terms of their complexity, their scale, their costs, etc. as well too.
Okay, yeah, sounds great. Let me start with bit of slides. I have demos as well. So yeah.
Perfect. This is great.
So
We have it up there. Thank you.
Awesome. So yeah, basically everybody knows that generative AI became extremely popular, and more than that, like it is a commodity. So you don't need to train your own model to use it, and you can use it for different applications. It could be like a standalone service. It could be a core product. It can be internal support tool. So that can be helpful on many avenues. The challenge is how to deploy it, and basically, like you need to compare different options and see how they work. So if we look at the usual data science project like process, like because you kind of work with machine learning, so the process is a bit different from classical software engineering. So you start with business understanding, you get data, you get model, you deploy it, and you get feedback from customers. So in real world, like it's a very iterative process. So you want to be able to start really fast. So you don't want to wait like months for gathering data, labeling data. You want to deploy something right now, get some feedback, and then based on this feedback, iterate more. And basically, specifically for LLM case, and probably David will dive more into the architecture of the standard app which utilizes large language models. But here, like a very basic architecture where like we have data injection part, which stores basically information in vector database. So this is like simple RAG. And when we do actual orchestration, we use this vector database to pull in like contextual data so that LLM can generate better response using better context. So in my case, I will cover specifically in this architecture like embedding models part and how to host LLM. So not the data ingestion part or how we store data, but like in a RAG application, these are also like pretty important parts. And in case with vector database, something like MongoDB Atlas can be used because like you need to have a way to store both like text data and vector data.
Perfect. I mean, I think that's kind of one of the areas I know when we've done these shows before, and then even at events when we're speaking as well too, you know, a lot of the questions come, you know, with regard to embeddings is how to choose those models, you know, which is the most suitable models, etc. as well too. You know, and that's obviously before we get into the area of hosting as well that you're going to talk about. So I think these are two key areas that our audience certainly will have questions for. So it's great to be able to dive into those.
Yep. Yeah. So when we speak about like hosting model, we have our standard inference challenges because we have model running in production. So it means we have to adhere to production requirements like latency, load, and cost. We need to scale, and we want this hosting to be flexible and integratable with existing infrastructure. In case with large language models, we also like have more requirements. So we have more specific inference frameworks, and we also have high memory usage because large language models.
Yeah, there's large in the title for a reason. They're huge, yeah. Or can be anyway.
Yeah. Yep. And if we look at the stack for the model deployment, we will see that basically we have to handle like different layers here. So starting with the model, basically, where do we store the model? Like, is it part of our container image? Do we store it on S3? Or do we use some private or public registry? If like specifically about large language model type, like what model type are we using? What's the number of parameters? Whether we need to apply like some optimizations, and whether we're using base model or fine-tuned model, which was fine-tuned on our data. On the code part, different options like here as well, like could be no code, like when everything is hosted and you don't need to go to this level, but could be that like if you need to control the whole stack, then you need to implement code for inference, some low-level optimizations, and model management in case you have multiple models. With container, the main part is which framework you will be using for inference. There is TGI, which is a framework released by Hugging Face, which is basically the most popular one. VLLM, which is also popular because it shows pretty good benchmarks. And LeetGPT and Candle. Candle also released by Hugging Face, written in Rust, so it's fast. As well as basically which base image to choose. And finally, choosing right hardware is important because on one hand, like, yeah, we want to use GPU because usually that means that we will have the fastest inference. But GPUs are pretty costly. And for some cases, CPUs could also be used. The problem is, like, to use large language model with CPU, you need to have some specific optimizations so that you don't wait for minutes for the response. So if we put like these like layers together and see, okay, here are different ways for deploying large language model on AWS. Basically, we will see this like spectrum of ways of deploying it. And here in orange is something which is controlled by AWS. So we don't need to handle that part. In purple is something we do need to control. So that's part which is not abstracted from us and we have control over. And here, basically, on the left, we have like more classic ways of deployment, like ECS cluster or AWS Lambda. And on the right side, we have very machine learning specific ways like Amazon Bedrock or SageMaker Jumpstart. And you can see that everything is in orange there. So basically, you just need model ID to start. You don't need to write a lot of code there.
Yeah, no, and obviously, you know, you're getting all of that level of abstraction. Developers being developers like to be in control of things sometimes. And, you know, I want to be able to fine tune and tailor this for myself. But I'm always, and look, I'm slightly biased because, you know, Atlas, our database as a service, says, look, we take care of all of your database needs. You know, you go ahead and build the best application you can. In this instance, and Bedrock is relatively new as well too. I think you're leveraging kind of the collective experience of a huge engineering team behind that. So even though everything's abstracted and in orange and they take care of everything for you, it's, you know, what would you estimate, Rustam, in kind of where would, you know, somebody new to this start? Should they go straight to Bedrock or somewhere in the middle or somewhere more towards the left?
Yeah, that's a great question. So Bedrock is definitely easy to start with, and like I will show like later like how the code looks like, and it's very simple, like literally like 2 lines. And another thing is that it's very easy to switch between different models, and it also adds a lot of additional business logic related to large language models, like guardrails. If you need to basically make sure that your content is moderated, or a knowledge base, which effectively helps to have native connection to your database to implement something like RAG, and agents in case you need to have your like Bedrock act upon the request, so that you don't have like a boring chat application, but you can actually tell it, okay, please invoke this AWS Lambda, and it will invoke it.
Yeah, I've seen some of the agent demos. They're incredibly powerful. Yeah, it really, it as you say, I think, and this is the thing, in my view, when you're talking to kind of more developers or people kind of playing with this space, they consider, you know, chatbot, sentiment analysis, RAG, etc. But for me, the more exciting areas is where we're getting into with agents, and I'm sure we can touch on that too.
Yes, definitely. And you made a very good point about like that developers want to have more control, but it's not like, how to put it. Here, for example, the 3 options here about SageMaker, they deploy the same thing like endpoint. It's just like using using same SDK just in different ways. So you don't have to have like a strong commitment towards a way to deploy it. You can start with one, and then you can decide to switch to another based on your needs. So it like infrastructure is always flexible, and you can basically start with something first and then evolve it based on requirements.
True, and that makes a ton of sense. Anybody entering this space at this point, as I think, David, you said when we were talking before we came on air, things are moving so fast. You need to be flexible. You might want to change your model, etc. So I think that is key.
Yep. So covering like each option here in a bit more details. So first is SageMaker Inference Endpoint deployed from SageMaker SDK. You can customize number of instances, and load balancing is handled by SageMaker, so you don't need to handle that part. And model itself can be referenced in different ways, and as I show later. And it doesn't have to be just endpoint. You can actually do like asynchronous inference or batch transform, or even serverless. So first option is SageMaker Jumpstart. Basically, it's zero code option. Like you just have like dashboard and you can deploy endpoint in a couple of clicks. So basically, if you go to Jumpstart page, you will see different model providers, even Hugging Face, and you can select proper model and just deploy it. With foundational models, you can basically select a specific model and reference it by ID. And you can do it through dashboard. You can also do it through the code. Another option is Hugging Face estimator for large language models. In this case, you can reference any Hugging Face model which supports TGI framework, and you can deploy it into your AWS account also with minimal amount of code. And to share more context, Hugging Face is effectively became GitHub for different models. So like if you have like particular model, even if it's like very niche, you can deploy it.
I love that analogy, GitHub for models. That's great.
Yeah. Yeah. So here's an example how the same Mistral model can be deployed using different ways. So first option is Jumpstart. You can see basically 3 lines. So I just import something from SageMaker library. I just need to reference model ID, and I say deploy this model. I basically tell number of instances and instance type. That's it. Next one is the same model referenced from Hugging Face. You can see that I need to write a bit more code, but not a lot. And I have a bit more controls over like what kind of Hugging Face Docker image I'm using. But in the end, it's still like number of instances and instance type. And finally, in case I decide to go with my own container, I can do that as well. So I can reference my own container, I can reference my own model on S3, and deploy it in the same way. And the main advantage of like these 3 methods is that they deploy the same part, like the same infrastructure, which you can reference by other infrastructure pieces. And finally, we have Amazon Bedrock, where like it's specifically managed service for foundational models, supports models from different providers, both open source and private, like Claude. And it has support for additional features, like which I mentioned before, like guardrails, knowledge bases, and agents. And you can even fine-tune your own model, but you will have to deploy it with provisioned throughput. And here example is even like the main thing to notice here is also 3 lines of code, but you don't need to deploy model at all. So here you invoke model right away because model was already deployed by AWS or by one of in case of Mistral, for example. So going back to the more traditional ways for model deployment, ECS cluster is also a way to do it. The challenge here is that you need to deploy a lot of pieces of infrastructure like load balancer, ECS itself, auto-scaling group, and maybe Spot Fleet. The main advantage here is that you can use AWS Copilot, which is a framework to deploy containerized applications on AWS. And it's like main limitation that it's limited to Fargate workloads. But here you can see the link with my blog post, which covers how to deploy specifically large language models using AWS Copilot. And next is AWS Lambda. So basically people love AWS Lambda because it's very scalable. You don't need to worry about like infrastructure part, and it can be integrated natively with other AWS services. So that makes the integration part easy. The main challenge here is that it's limited to CPU workloads, and it has cold start issue, but that can be managed by SnapStart. Just want to cover SnapStart a little bit. The main idea here is that instead of like starting the whole Lambda from scratch, it saves the snapshot of the initialized Lambda, and then it can invoke a Lambda not from scratch, but from the saved snapshot. And that helps to significantly reduce cold starts. Its main limitation that it only works with Java, and it's subject to 250 megabyte package limit, which is not a lot in Java world. And here you can also check my blog post on how to use it with Onyx. And if your model supports Onyx, then you can benefit from using it with SnapStart.
Okay, very clear. Okay.
So yeah, now let's go back to the inference stack. So here we have this stack like on high level. If we compare them in more details, I know this like table is large. Here I kind of tried to, how to put it, put more detailed axis of comparison. Basically, because with large language models, we care about things like what's maximizable RAM or CPU or GPU, and are we limited in terms of specific frameworks? And what would the cost look like? Because, for example, the more control you have, more detailed cost you have as well. So, for example, with ECS, you pay per EC2, per load balancer. With Jumpstart, you just pay per instance, or with Bedrock, you even pay per tokens. So very clear cost. Doesn't mean that it will be low.
That's a cautionary tale, yeah. But it makes it easier, obviously. More abstractions, less cost to manage, but maybe not less in cost. Fair enough.
Yep, definitely. So if we look at like the most important part, because like cost is very important, and compare different ways of like managed base models, and like to give a heads up, base models usually cheaper than fine-tuned models, because fine-tuned models you have to host on your own infrastructure. Base models are shared across different users, so that's why they're a bit cheaper. So you can see here that like Amazon Bedrock compared to GPT, like they more or less like around the same cost. There are some cheaper or more expensive options. Usually, like if you have more complex models like Claude 3 or GPT-4, they're more expensive. But with some open source models like Mistral or Llama, they can be extremely cheap. So you can start using it. If it works for your application, then it means that it's very cost effective to start using it.
It's great to see that table, Rustam, because it's something that also comes up in questions all the time. It's kind of, what do I choose? What service do I choose? What models do I choose? But also, what's the cost? And ultimately, there's a trade-off between getting started quick and easy from a developer's perspective to this is now in production. What is this going to cost us to keep it up and running?
Yes, definitely. Cost is becoming non-functional requirement. And like now developers need to think about cost as well, because previously like you only had to think about latency and like is it what's the ON of your algorithm or something like and now you need to care about like cost of your code as well.
Yeah, we've even seen it in some of the demos that the DevRel team here at MongoDB put together. It's like, it gets up and running, and then all of a sudden they, somebody gets a bill somewhere for it. And it's like, oh, right. Who else is using this demo? How did it spin up this amount of cost, et cetera, as well, too? So it is something that developers, as you say, now need to be very aware of, not necessarily cautious, but just aware of the cost implications.
Yep. And basically, if we like something I mentioned before about CPU versus GPU for large language models, basically keeping in mind like number of parameters and different optimized frameworks. Also some optimizations you can do for CPU, like quantization and reducing precision or removing unused weights. Also, there are a lot of interesting projects out there which try to make large language models smaller, like Lamini or Tiny Llama. which effectively they try to train from scratch models which have like 1 billion parameters or less. And kind of similar to the slides about cost, but this time it's hosted. So now you have like full-on instance where you host your model. Here it's Mistral 7B or similar model. Like the important part is the following. First, cost per month is it costs a lot because GPUs are expensive. So not a big insight here. If you look at the cost per 1 million token, because it works pretty fast. It's 30 milliseconds per token, 13 dollars per token. It's very expensive compared to like base model, like if using Bedrock for Mistral. So it's definitely cheaper to use that. But if you have to use fine-tuned model, then you don't have an option. But you can see that with CPU, you can start using it. And the advantage here is that cost per month is lower, but your duration per token is also higher, like because it works slower. And it can become like more expensive per 1 million token, but less expensive per month. So again, it's something like to keep in mind when you design your architecture. Another thing to mention here is that you can use more, like G5 is NVIDIA basically GPUs, but you can utilize Inferentia, which is AWS chips, for hosting large language models. Usually it will provide similar duration per token, but it's significantly cheaper per month. So basically you have the same performance, but it's significantly lower cost.
Okay, makes sense.
So yeah, basically, if you put this stack together, like we can see that we have either more control on the left or like something like easy to start with Jumpstart or Bedrock. And if you think about it from the project lifecycle perspective, you can start with Amazon Bedrock. And depending on like your requirements or needs, how they evolve, you can switch to different options. So if you need custom model, you can switch to SageMaker Hugging Face. Or if you need to have like more custom code or libs, you can use custom Docker. Once you have custom Docker, it's very easy to switch to ECS because now you control like Docker and code and libraries. And in case you need custom infra or want to decrease costs. And serverless, sadly, not there yet. So you can see that it wasn't part of the picture from on the previous slide. That's because like cold start is several minutes, which is pretty prohibitive for real-time applications. Could be used for event-driven applications, but not there yet. What would change that is if SnapStart is introduced for Python Docker, no cold start issue for large language models, or GPU for Lambda and Fargate. That would result in faster inference. So yeah, now let me show my demos.
Excellent.
So that will be pretty quick. So here first we can see SageMaker Studio. Just want to show you how Jumpstart looks in reality. So you can see that there are several providers. You can select from like different models from them. So something like Hugging Face, you can see a lot of different models. I already deployed an endpoint, but basically when you select, let's say, Mistral, you can just click deploy. You can select your configuration and then just deploy it right away. What you will see here is like the endpoint, which you can even test without even writing any code. So here you can send requests to the deployed endpoint and see how it works. This is like basically the managed part. Another part is AWS Copilot, which is I have already deployed, and basically it returned me a service which is accessible through endpoint here, which also hosts Mistral. And you can see here that I can send it some sort of request with some question, and it can respond to me back. A bit slow because it is hosted on CPU, but you can see that it can. Yep. And the advantage of ECS Copilot is that it will deploy the whole infrastructure, like you can see the whole like cluster with different tasks. And you can even define auto-scaling rules and so on. So here, basically, you have the whole like real production infrastructure without need to customize it on your own, because like you will see that like here I just basically ran Copilot deploy and that's it. So that's basically it on my side.
Excellent. It was great to get that overview and to get that comparison across the whole inference stack that you shared, and to get that understanding of both deployment, what's easy to get started with, what's a little bit more customized, to get an understanding of the costs. I think this is probably the first instance of Cloud Connect where we've gone into cost. It's usually not a table or a feature you see up in any developer kind of presentation, but it is super important, as you said. And then for you to run us through essentially, SageMaker, Bedrock, Lambda, ECS, etc. Rustam, I think you've made what can be quite a difficult landscape for a developer to navigate. Where do I start? What services do I use? What's the best for my application? So it's great to see that you covered both bases of that and then quickly into the demos as well too. So thank you so much. That's been great. And if anyone has questions, I know we covered an awful lot there. Anything comes to mind or any other questions for Rustam, please throw them into the chat. We'd be more than happy to take them on board. Rustam, you're getting a shout out or two in the chat as well. So from Seattle, so it's always good to have those kind of compliments come in as well. Thank you so much for exploring that. So David, Rustam obviously had RAG mentioned in there as well too, and RAG is becoming quite prevalent for people who want to leverage large language models, but obviously on either a specific area or some corporate information or some corporate know-how, etc. as well too. So let's get into that a little bit more and kind of take it from your perspective as well too.
Yeah, let's do that. Yeah, by the way, great contents, Rustam.
Thank you.
Yeah, so taking it from there, so I want to dive a little bit deeper on RAG. So retrieval augmented generation. Basically we want to cover two key points: vector databases and large language models. And I'm going to use the illustrations to explain some of the concepts. And so let's see. I think, just like doing internet search, I think most of us has done some sort of large language model experience, right? So you put in your input prompt and the model generates the output, and then we get the output text, right? So in a LangChain, this is expressed in a simple format like this, very easy to understand. And perhaps we can try that in a little demo here. So I think I want to make it practical, right? So maybe we can use language model to learn some new things. So I'm using Anthropic Claude 3 Haiku model. And let me ask a question about.
Oh, I'd be interested to see what answer it gives back.
Yeah, you can fact check this, right? So I think, so what I'm getting is this large language model was pre-trained with large corpus of data, right? So it even understands MongoDB TV and give you the sort of summary of what it is. And then
you did a great job. I couldn't have done better myself. We might use that in future explanations to potential guests.
Yeah, exactly. And then the recent model that came out, Claude 3, runs on Amazon Bedrock, has a vision capability as well. So, I can also take a look at the, let's see here. So I've got the Amazon Bedrock console, basically this console page. When you come here, you can see the choice of foundation models. So what I did was I took a screenshot and then try to feed that into a language model, right? And then see what kind of response I get. So I'm gonna give instruction that, hey, explain this image for me. And then Haiku, it's just a very sort of performant model, very cost effective. giving me the response. And I'm also using the Amazon Polly to turn this text response into voice as well. So I can either listen to it or take a look. Now, on the Spotlight, it talks about the new models, Haiku, Sonnet, and Opus. Haiku and Sonnet, they're available today, and Opus coming soon. And just want to highlight, it captured the 200K context window, right? And then present it back to me from the image itself, right? So in this case, the model had pre-trained knowledge and then understood the image and then gave me a text response, just like this, right? So at this point, we didn't use any RAG at this point. We are simply using off-the-shelf model and doing text generation here, right? So comparing the basic chain, let's take a look at RAG chain in this case. So this part on the bottom right-hand side looks familiar, right? Prompt goes in to the model and output comes out. Now, the difference is that we want to insert context based on user's question. That's expressed in this LangChain language. But I think the main difference here is that there's a retriever component that takes the user question and then retrieves relevant chunks, relevant context, and put that into the prompt so we can help our model to generate better output. Right? So in this case, I think we talked about the service from Amazon Bedrock, fully managed service. And so perhaps instead of me telling you what RAG is, what I did was I put in the white paper from MongoDB.
So very good.
Yeah, that's right. So it basically retrieves the relevant chunks, and then LLM synthesize a response based on that. And now I have the context information, the source of truth, the citations that I can refer to, number of score, where the source is, which is sitting in an S3 bucket. And then I can make sense of the response as well as the source data and try to take it from there. So it really helps. I sort of treat these models as my coworker, right? How I can leverage these models, and we have a variety of models I can choose from Bedrock. So yeah, let's dive a little deeper on this syntax from LangChain, because in the prompt, typical the text generation, text prompt as is, but in this case we have extra hop here, and then we have the prompt engineering here, very simple, telling the model that answer the question based only on the following context, and then I'm going to fill in the question as well as the context. So when the model sees your prompt, then I not only see your question but also the context that's retrieved from the vector store.
And I think that's key. I know I mentioned at the beginning, but one of the things also this RAG helps is up-to-date information, right? A lot of these models, look, a lot of them are getting much quicker, much closely trained to today, obviously, but they are at a certain point in time. So if you're looking for up-to-date, kind of current transactional data, whatever the case might be, this is really where RAG stands out for me anyway, in that context. Not only the information that the models are not trained on per se, or information that is kind of closely guarded or within a company, etc., but also the up-to-dateness of things as well too, right?
Yeah, that's a great point. I think of this model as sort of isolated, right? It doesn't have access to internet. It doesn't have access to the latest information. So if you can help your coworker by fitting the context, I mean, we can get much better output, right? So, all right, so moving on. So let's dive a little deeper on the retriever. So retriever's role here, which is the key component of the RAG system, right? Because the quality of the response really depends on the quality of the retriever. So retriever takes the question and it provides the context. And in a LangChain, we define the vector store and then use it as a retriever function. So, putting it all together here, again, we understood sort of the structure of it. I think from an expression language point of view, you've got this dictionary where, I'm going to pass on the question, just pass through it. And then I'm going to also take that question to the retriever and then populate the context. Now, at the core of it, I think we want to also explore the vector store. And you can see on the left-hand side, you have the pre-processing phase where you have your lots of documents that you want to ingest, and we want to chunk it. We want to use embedding model to turn this text data into numerical numbers the model can calculate. So that's stored in the vector database before the runtime. And now when it comes to the runtime lookup, a retriever function, the user could ask a question, retriever takes that question, again goes through the same embedding model to turn it into the numbers. And then we run this algorithm to get the k nearest neighbor response, right? And then feed it into the context. So that's sort of a high-level overview of the RAG system. And this is part of the blog that I posted. So we'll go ahead and share that as well. Oh, so looks like my browser is frozen. Hold on.
Yeah, it seems that way. Maybe we can add it again, David. Don't worry.
Yeah.
Perhaps it seems like your video as well too. Unfortunately, maybe I don't know, Rustam, if you're seeing that too. This is a live stream. The live is in the title for a reason. These things happen. David, let's see if you can share that browser again, and then maybe everything will kickstart too.
Yeah, let's.
We can still hear you anyway, so no problem there.
Okay. Yeah, sorry about that. I'm getting a spinning wheel here, so I may have to restart my browser.
No worries, no worries. That's fine. We'll take the opportunity to throw out the call for questions coming in on the chat as well too. If you've anything that either from Rustam earlier or even what you just saw with RAG and well explained. If you want, David, I can pick up that screen share as well too, maybe. If you want to give me that link in our private chat here, I can do that and throw it up on the screen and we can get that. While I wait for David to join us again, we do have some great tutorials, some great Gen AI tutorials. Thank you for the call out. I know it shows up here as LinkedIn user, but that's because of our integration. But I do know for a fact that this is Bill. Thank you very much, Bill, for sharing that with us and our viewers as well too. For all of the things that the DevRel team create here at MongoDB, the best source to go there is to developer.mongodb.com, and you'll find our developer center and all the articles, including the Gen AI. We do have a filter. You can go and pick AI in the Dev Center, and you'll see all the articles across all of the topics, all of our cloud providers, and in this instance, obviously, all of the work that we've done with AWS in that space too. Rustam, it's you and I. So while we wait for David to come back, oh, there he is. Hold on. There you go. You're back anyway for us. You're back live anyway.
Oh, sorry about that.
No, these things happen. It's a live stream. It just goes to show how it really works.
Yeah, it's technical issue right here. Let me see if I can share my screen again. All right.
Yep. There you go. It's all back up. That's great.
All right. Take two. So
no problem.
Yeah, at this point, so we just went through the RAG concept in a simple LangChain expression language, which is very sort of declarative way of defining your chain and sort of workflow. right? So I want to give you some, sort of use cases where maybe we start off with image search. I think one of the, even without the language model, the vector stores has a lot of, it has a lot of value, especially doing a semantic search. And we've got the multimodal capability as well. So I have my MongoDB cluster. There you go. And I have the collection. So I ingested the, let me go a little. So ingested the image data in terms of the file name, location, and here's the embedding, right? So embedding is nothing more than sort of the array of decimal numbers that represents that data, in this case, image, with text. So I have this, and I have the vector search, and you can see in this multimodal. And if I take a look at index I created, you notice that the embeddings dimension, as well as the similarity search mechanism, which is cosine search. So using that, what I'm going to do is I am going to take the image. For example, in this case, this is an image from AWS, talks about what RAG is. So again, using RAG to learn about RAG here.
I love it.
Yeah.
Brilliant.
I ingested my images that I posted. So, based on, hey, this image looks like RAG system. And so it went ahead and retrieved the, RAG chain we just went through, and then the vector store image as well, right?
Excellent.
So that's interesting.
Mm-hmm.
Now, as far as the, we can also use text as well. So text search, let me look up some images around retrieval. So it went ahead and retrieved the vector store function, as well as the additional image related to retrieval augmented generation.
Mm-hmm.
So we don't stop there, right? So, we understand that Haiku model has a vision capability. So, putting it all together, right? So Titan embeddings model, which is multimodal capable, MongoDB Atlas, vector search, and then the vision model. What we can do is we not only retrieve the images, but also feed that into the model to generate the response. So again, I'm looking at the retrieved images. I'm feeding these two images to Claude 3, and it explains what those are, and then gave me a voice response as well. And you notice that the response is really fast. It's a lightning fast, and Haiku really sits in that sweet spot of performance, the price to value. So.
Okay, so yeah, going back to what Rustam had up, there is sweet spots, right? You need to figure that out for your particular application in this instance. Okay.
That's right. So going to, again, we went through the knowledge base, and then we have the retrieval augmented generation. So again, you can use the fully managed knowledge base or even Amazon Q. At the same time, if you want to have more control, and you can build your own RAG system, right? So in this case, I'm demoing the parent document retrieval, which is more advanced way of retrieving the right information. So you have smaller chunks and in larger chunks, parent-child relationship, which is stored in the MongoDB. Again, I have a collection of the data. You notice that I have about 336 chunks. It combines the parent as well as child relationship. So what it does is it retrieves the smaller chunks, and the smaller chunks may not have the full context. So once I get the smaller chunks, and then I get the parent chunks as well, and then feed it into a language model to produce more contextual, relevant information.
Okay, understood.
So I think one of the sort of questions, we might have, let's see. So let's use this. Yeah, so I have prepared a few questions here. How does MongoDB facilitate the operation of the rack system, right? So let's do that. So again, it's looking at the white paper. Feel free to take a look. It really goes into the deep, the in-depth. But then I think instead of sort of me personally going through each information, learning it, I think we can also rely on Bedrock to give me a response. So just taking a look at the summary. Yeah, so again, you can take a look. I think the key component here is that the leveraging the vector search and be able to, use it as part of your application, right? So, start embracing this technology in a meaningful way and start, making an impact. I think that's the whole idea here. So.
Yeah, no, it's very powerful, and it's a very performant coworker, as you were calling it as well there, David. I mean, there's a lot of opportunities there to, ingest and absorb a lot of very, detailed information quite quickly in this instance. And these summarization abilities of a lot of these tools are incredible. And, you passed it in I don't know how many pages are in that white paper. It's a while since I had a look at it, but yeah, it's a pretty large white paper in fairness. And to get, 6 bullets back from that, that's ideal to grok something quite quickly, right?
Absolutely. Yeah, I'll pause here at this point and I'll pass it back to you.
Excellent. Well, look, I think for us, again, like Rustam, David, thank you so much for clearly navigating us through. And I love the way you leveraged your Medium article in through the presentation and then actually into this demo here that you were running locally, from chat to chat with vision and image searches as well too. And, image search plus generate, and then obviously all the way right up to Bedrock as well too. I think that's a lot of food for thought for most of our audience to take on board, but it shows the power of what we had. And I think, as we said, probably maybe at the beginning of the show or maybe just in our pre-show chat, we're only at the beginning, right? I mean, Rustam, you said at the beginning you've been in machine learning for a long time, but the last 18 months have been hectic in the world of generative AI. What are your thoughts?
Yeah, definitely. And yeah, so, but I mean, that's I think what I like about machine learning. There are waves of new hype. So like over the last 10 years, I think there were like a couple of them. So it's always something new. So when you work in the field, like, how about it? I think there's always time to enter the field because always something new is happening, which completely removes all prior knowledge. So I think from this perspective, it's always like a good time to enter the machine learning area.
Yeah, look, I think that's it. And like anybody I talk to who's seasoned in machine learning and this space, I hear what you're saying. Waves of new hype. This seems to be a particularly big wave. Has gone on for quite a while. But look, let's see. And I suppose lots of companies are involved. And as you've shown there, David, what AWS have been building and putting out there through all its various tools and products that it have is extraordinary in terms of what things can do now. And how do you both keep up with what's going on in this space? David, like, how do you keep abreast of all of these developments? Is it through blogs? Is it through podcasts? Is it through talking to colleagues? What way works for you?
Yeah, so I spend a lot of time social media. I think I follow a few sort of popular individuals who constantly, push out contents. Again, it's sort of moving speed of light, and so just keeping up, it's just work of its own. But I think at the end of the day, if you have a passion and then curious, just bring your curiosity, right, and then having fun, just having, I think, just like I said, sort of having multiple coworkers, working with me, and then I think at the end of the day, making some material impact, right? And then get some result, and sort of doing the cycle over and over.
I love that the passion and curiosity. Rustam, some advice for, I think one thing that stands out for me in this space is, bar, the core tenets of machine learning and the things that have been around for 20 or 30 years. There's people can jump into this space now because there's no seasoned developers out there in this space. It moves too fast. It's not, it keeps moving. Where would you, for somebody, and we got a comment in there from Alexandra to say, looking forward to building RAG apps with Mongo, and that's great to see. Thank you for the comment. For somebody looking to get started, where could they go? Where is a good resource for them to get up and running? In your view, Rustam?
Yeah, that's a great question. I think there are a lot of courses about the large language models and generative AI, and I think I will need to check the website, but it's called deep learning courses like .ai or something.
Okay.
And basically, I will send the link in chat. But yeah, it has a lot of great courses on machine learning, deep learning, and specifically generative AI and large language models.
Okay, so that's one
It's deep
area
learning,
to
yeah.
go to and get started as well too. And same for you, David. Where do you have any places that you've seen recently that if you were just getting started in this space, you would use as a go-to destination?
Yeah, that's a great question. So I used to use so we have an open source framework. It's AutoGluon. That's it's AutoML framework, and I used that to do Kaggle competition, right? So that's a lot of deep expertise. People compete competition. So I used to do that using simple AutoML, and I was like making it to rank top 10 or top 100, right? Which is hard to do without having PhD. So I think similar sort of exercise, whatever you can sort of run with simple concepts. I gained my new passion for Python, leveraging language model. I couldn't quite learn so far up to this point, but I think just with the support of language model, I was able to learn. So with mixture of your coworker language models and other things, and you can start learning today.
Excellent. And Rustam, you touched on agents earlier when you were going through your own demo and presentation as well too. Is that what excites you most about what's coming down the tracks for a lot of this generative AI space, or is there anything else that really excites you that may not be, so much in the public eye for some of our viewers?
Yeah, that's a great question. So I think agents is just like a new frontier. Well, because I'm even more excited about because right now we established that chats could be useful with these assistants. So even when we have something like RAG, it can answer very complex questions with a lot of context. But the real question is what can happen beyond that? What can happen? Okay, it can answer questions, but can it actually act on the question? Can I ask it to do something based on the response? Because right now we saw that you can connect multiple things. So now you can not only first you find similar images, and then you can ask something like Claude to explain these images and get response back to you. And maybe next you want to basically, actually you want to deploy this architecture, and then it will find correct components and deploy them into your AWS account.
Yeah, and I think obviously, David, Bedrock has capacity for agents, right? And it's kind of really only getting started at this point in time. I mean, I suppose Bedrock's the bright future. It was over to the right of Rustam's chart there. It abstracted a lot of things for you, but agents are a key part of Bedrock's roadmap, right?
Yeah, absolutely. I think agents are creating a lot of buzz, but I think we also need to understand there are some non-deterministic behavior, right? So especially dealing with language models and generative AI overall. So I think the beauty of Bedrock and building on AWS is to leverage all the services that you have access to. I think if you just use AWS Lambda as a tool for your language model, I mean, you're unlocking full potential. You can build pretty much anything, right? Programmable. So I'll start there, and also slowly ingest agent capability as well, to be able to automate some of the workflows.
Okay, and maybe this is a co-worker, maybe this is somebody who knows, but I'll direct this to you, David. Party Rock. I've seen the website. I know what it's about. Can you explain to our audience what Party Rock is?
Yeah, absolutely. So Party Rock. So we just rolled it out, and I think a lot of people are building it. So again, for non-technical individuals that wanted to kick the tire, start building application, Party Rock is there, and it's really simple process to create your own creativity, right? Output from your idea to outcome. So give it a try. I've seen people having really fun creating some interesting applications as well. So looking forward to seeing some new ones.
Excellent. And the that website, thank you, Rustam, for finding that link that you mentioned earlier. There it is, for deeplearning.ai. So you can pop over there, and if you're looking to get started, as Rustam said, there's a wealth of information in there. And obviously, I know both look from a MongoDB perspective and AWS. If you go on to any of the sites, as I said earlier, there's plenty of tutorials. And if we have an opportunity, I know, David, that AWS summits are all starting. First one in Paris next Wednesday, and they'll continue on throughout the next number of months, all culminating with reInvent at the end of November, beginning of December. Will you both be there this year? Fingers crossed.
We'll try, certainly.
Excellent.
Yes.
Well, look, I mean, that's 6 months away at this point in time, or a bit more. So this space could be entirely different. As we said in the introductions, you both did some presentations on the MongoDB stage there, or there are stands there at reInvent. So hopefully we get you back. Who knows what those presentations might entail. 6 months. 6 months is a long time in the tech world. It's a very long time in the generative AI space. So we'll see what happens down the road. We've had a great session here, lots of comments coming in. I think people kind of really enjoyed what we've gone through. As we said at the beginning, this is recorded. You can go back through it. And both Rustam and David had to cover a lot of information in quite a short period of time as well, too. Any last parting comments, Rustam, for anybody looking to get started or learn a bit more in this space, or any kind of cautionary tales for people to be concerned about? You talked about costs, which doesn't usually come up on the Cloud Connect show too much. Is that the cautionary tale?
Yes, that's definitely a cautionary tale. But I think things like Party Rock is already, like, if you want to understand how it works, that's a great playground, and it's free. So if you want to kind of understand how you can connect different LLMs together and how you can develop LLM applications, that can be a good starting ground to kind of familiarize yourself more with the space.
Okay. And David, how about yourself? Any kind of parting thoughts, kind of pieces of advice for our audience looking to get started as well, too?
Yeah, I think, take a look at what you're good at. I mean, you have domain expertise, your specialty, which is your power, right? Superpower. So by having, these language models and, generative AI tools to augment and enhance your domain expertise, and start looking for use cases where you can apply these.
Perfect. We just got a late question in there, probably directed mostly to you, David. Text to video, is that possible in any of the AWS services at the moment?
Yeah, so we have a few the image generation models, both from Stability AI as well as Titan model. We have a preview for that, so take a look. In fact, I had a demo for it, but with the interest of time, I can save it for later. But yeah, take a look at the Amazon Bedrock console, and you'll be able to find it.
Okay, and Carissa, who joins us from Hawaii, who's a colleague of mine on the DevRel team, who you both know because she got you together for our stand at reInvent, is quite alarmed that we're already talking about reInvent. It seems that reInvent just happened. Carissa, 5 months ago now at this stage, we're heading towards midway towards the next one. So watch this space. We'll see what happens. Well, look, I think this has been, superb, kind of really both a high-level overview, but a very detailed overview from both of you. I think we got into some really interesting demos there. Rustam, what you showed. I think the way you navigated, I suppose, that whole kind of inference stack was super clear to me. And I love the way that you illustrated that and the options and the levels of control that you might have as a developer, going back to the 3 lines of code versus more than 3 lines of code, and in some instances all the way up to Bedrock with no lines of code and things like that as well too. So that was superb to see all the deployment options that are available to most developers. And David, then to go through and really explain how RAG, which I think is, I see so many companies looking to do, I see companies who just are startups doing RAG in very specific areas on very specific topics. And I think that's going to be kind of a secret sauce for a lot of these companies. I think it's incredibly powerful, be able to do what you did, take a PDF, upload that, and then query that. Super simple. So the Medium page that you put up there, David, I think I have the link here. Let me see if I can grab that really quickly to get it up to as a banner for our audience as well too. But people can play around in there on your page, right?
Yeah, absolutely. Yep.
Let me see. I'm sure they can just search for you as well too, because they're never going to be able to take that one down. And excuse me for lazily copying and pasting it, but just go and search for David Min on Medium, and you're going to find what David ran through with us as well too. This has been superb. You've been great guests. I really enjoy. Hopefully, I will get to meet you at reInvent if you do get to go, and we can chat in person. And I'm certainly going to try and figure out some other opportunity or some other avenue to have you both either individually or collectively back on MongoDB TV Cloud Connect. But for today, this has been superb. I thank everybody that joined us from around the globe. I was keeping an eye on where people were tuning in from. And, for all of these streams, we love to see that. So if you enjoy this, please share this amongst your colleagues as well too. That's always good. And as I said at the beginning, if you want to do something with MongoDB in person, keep an eye out on our website, mongodb.com/events. We'll show you where our forthcoming .locals are. And with respect to David here, if you go to AWS and search for summits, you'll see all the various locations around the globe where those summits are kicking off in Paris next Wednesday. I think that's about it from me. This has been superb. Thank you both so much for your time and your preparation. We do appreciate it. So for now, Rustam, David, thank you very much. This has been a great show. Please join us on Cloud Connect in the future. And thank you to all the viewers. We'll see you next Thursday as well too, which, surprise, surprise, is more generative AI as well too. Take care, everybody. It's been a pleasure. Thank you, David. Thank you, Rustam.